Hey everyone, welcome to this explainer. If you're an infrastructure admin gearing up for the Nutanix NCP-MCI 7.5 certification, you are in exactly the right place. Today, we're zeroing in on a crucial topic, NCP-MCI 7.5, 10.8 VM level security, vTPM, Secure Boot, Credential Guard. We aren't just going to sit here and read through dry documentation together. No way. We're going to completely break down the specific architectures, the deployment workflows, and most importantly, the exact edge cases you absolutely need to have memorized to pass this exam. And just to set our baseline, we'll be looking at these features specifically through the lens of AOS 7.5 and AHV 11.0. Okay, let's quickly check out our roadmap for today. First up, the foundation. Second, we'll do a walkthrough of vTPM and Secure Boot. Third, a walkthrough of Credential Guard. Fourth, external KMS keys. Fifth, we'll navigate the exam traps. And finally, we'll wrap up with the final 4 cheat sheet. All right, part 1, the foundation, neutralizing threats at the VM level. So before we even think about configuring a single setting in Prism Central or a CLI, we really have to understand why we're doing this in the first place. Look, in modern infrastructure, perimeter defense simply isn't cutting it anymore. We have to neutralize threats down at the VM level itself, specifically going after devastating attacks like credential theft. Nutanix AHV gives us a robust suite of tools to lock down that guest operating system from the absolute ground up. Let's anchor our foundational acronyms for the exam right now. First up is UEFI. This manages a secure startup process, effectively kicking legacy BIOS to the curb by ensuring only signed, trusted code actually executes during boot. Then we have vTPM, or Virtual Trusted Platform Module. Now here is an absolutely crucial point for the exam. AHV vTPM is an entirely software-based emulation of the TPM 2.0 specification. You literally do not need physical hardware TPM chips installed on your Nutanix nodes to use this feature. It functions as a virtual device presented directly to the guest VM. This lets you manage cryptographic keys for essential workflows, like Windows 11 installations or BitLocker drive encryption, without relying on any underlying host hardware modules. It's a real game changer. Building on that foundation, we really have to look at how credentials are historically stored and why changing that matters so much. In a standard operating system, credentials just sit there in relatively accessible memory. Imagine this scenario. A seemingly harmless phishing email lets an attacker execute a really basic script. They can instantly scrape that standard OS memory, dump the hashes, and boom, they've got the keys to your kingdom. It happens every single day. But when we enable Microsoft's virtualization-based security, or VBS, on AHV, we fundamentally shift that entire storage paradigm. VBS creates a highly protected, isolated vault for those credentials, entirely separated from the main OS memory. So even if that same attacker executes their script, they hit an impenetrable wall. The memory where those credentials live is fundamentally invisible to the compromised OS layer. It's like hiding a safe in a room the thief doesn't even know exists. Let's move on to part 2, walkthrough 1, Windows 11 and BitLocker. Let's see how this all comes together in a real-world scenario. Say you're tasked with deploying a Windows 11 VM that strictly requires BitLocker encryption. Well, Windows 11 mandates TPM 2.0 and Secure Boot for optimal security. So how are we configuring this on AHV? For this to actually work, you must follow a very specific chain of dependencies in Prism Element or Prism Central. Step 1, your VM must use the Q35 machine type. Why? Because the older i440FX machine type relies on a legacy IDE bus. That old bus simply cannot handle the modern, secure hardware handoffs required by UEFI. Q35 uses a modern PCIe architecture, which is a non-negotiable, hard requirement for attaching a vTPM. Step 2, enable UEFI firmware. Step 3, check the box for Secure Boot, which effectively tells the hypervisor to enforce signature checks on the bootloader. And as a quick aside, note that enabling Secure Boot automatically enables UEFI by default. Finally, step 4, attach the vTPM. If you miss those Q35 or UEFI prerequisites, your vTPM and BitLocker deployment will just outright fail. All right, part 3. Walkthrough 2, defending against pass the hash. Now imagine a slightly different scenario. You aren't just deploying Windows 11 desktops, you are tasked with securing a massive fleet of critical Windows servers against severe credential theft, specifically things like pass the hash or pass the ticket attacks. This is exactly where Windows Defender Credential Guard comes into play. Think about the architectural flow here. At the very base layer, you have the AHV hypervisor. Sitting right on top of that is the VBS-enabled guest VM. Now, inside that guest VM, Credential Guard relies heavily on Microsoft's virtualization-based security to run a completely distinct VBS instance. This VBS module securely locks away the credentials, isolating them completely from the standard Windows OS and user apps operating over on the side. Even if advanced malware heavily compromises the standard Windows OS, it physically cannot cross that virtualization boundary to access the isolated VBS module and steal the hashes. It's brilliant. Okay, I need everyone to pause and pay close attention here, because this specific caution is one of the most critical concepts for the exam. Enabling Credential Guard is incredibly powerful, yes, but it comes with a massive architectural trade-off. Because Credential Guard uses a distinct VBS instance, it introduces what we call nested virtualization overhead. You are effectively running a hypervisor within a hypervisor to maintain that strict security isolation. As a direct result, your overall cluster VM density is going to drop, and individual VM performance is affected. The documentation explicitly recommends testing this in a non-production environment first, just to baseline the performance hit. If you skip that step and just boldly roll this out to your entire cluster on a Friday afternoon, you are going to be watching CPU spikes ruin your entire weekend. Seriously, don't be that admin. And absolutely do not forget this trade-off on test day.
Part 4. Securing the keys. External KMS integration.
So once you've successfully attached to vTPM, the cryptographic keys themselves require bulletproof protection. Think about it. The vTPM is entirely useless if the keys securing it are lost or compromised. To protect vTPM-enabled VMs properly, the security guide dictates that you absolutely must back up those keys regularly. Now, Nutanix does offer a native key manager, or NKM, but when you are scaling out software data at rest encryption and vTPM deployments, the exam is going to heavily test your knowledge of external key management servers using the KeyMIP protocol. KeyMIP is the industry standard for cryptographic key management. You must ensure this external KMS remains highly available, you have to perform periodic key backups through it, and strictly store those backup files in a secure, external location that is totally separated from the cluster itself. So why is this external separation so absolutely critical? Picture this. You suffer a massive cluster failure. It's incredibly stressful. Alarms are going off, but you keep your cool and initiate your disaster recovery plan. The VMs sync up, the networks fail over perfectly, you go to power on your most critical vTPM-enabled servers, and they sit there, entirely dead in the water. Why? Because the external KMS backup file was sitting on a completely separate server that also went offline, and you never actually backed it up off-site. Without that KMS backup file, the cryptographic lock simply cannot be opened, and your virtual machines will just fail to boot, period. Your data remains permanently inaccessible. The exam absolutely loves testing this exact disaster recovery dependency, so commit it to memory. Section 5. The minefield. Exam traps and edge cases. Let's shift into high alert and walk right into the minefield. The NCP-MCI exam tests your practical administrative knowledge. That means it will relentlessly test you on limitations, minimum requirements, and those tricky edge cases. Memorizing these version numbers is basically non-negotiable for passing. Credential Guard has been supported for quite a while now, requiring AOS 5.19 and AHV 2020-10.07.1. However, vTPM is a much newer feature. It strictly requires at least AOS 6.5.1 and AHV 2020-03-04-24.2. If an exam question presents a scenario with a cluster running, say, AOS 5.20 and asks you to enable vTPM, you know immediately that it is unsupported. Do not get tricked by mismatched version requirements. Also, you really need to watch out for CPU architecture constraints during live migrations. If you have Credential Guard enabled, live migrating those VMs on Intel hardware strictly requires the Skylake generation or newer. This is because Skylake introduced specific hardware instruction sets, like mode-based execute control, which VBS heavily relies on to function seamlessly during a live host transfer. If you expand a cluster and add an older Intel CPU node, Prism will immediately throw an alert stating VMs became non-migratory due to node addition. Interestingly enough, though, if you are running modern AMD processors, they do not face this specific generational limitation for live migration. Now, when we talk about disaster recovery, the rules get even stricter. Let's tackle these methodically. First, cross-hypervisor DR, or CHDR, is entirely unsupported for vTPM VMs. You cannot fail over a vTPM VM from AHV over to ESXi. It just won't work. Second, if you want to use asynchronous replication for a vTPM-enabled VM, both your primary and recovery sites must be running at least AOS 7.3 or later. Finally, and this is a massive exam trap, Third-party backup tools are completely blind to vTPM data and keys. Because these third-party tools only interact with the standard hypervisor APIs, they lack access to the external KMS and cannot pierce the VBS or vTPM cryptographic veil. To them, taking a backup of a vTPM VM without the KMS integration just means backing up a bunch of encrypted gibberish. Let's wrap this up. Section 6. The final 4 key facts to memorize. You've navigated the minefield perfectly. Let's lock in this masterclass with a rapid-fire summary of the absolute must-know data points before you sit for the exam. Here are your final 4 takeaways. Number 1. Secure Boot strictly mandates the modern Q35 machine type. Number 2. Credential Guard leverages VBS, which inherently taxes your cluster density due to nested virtualization overhead. Number 3. External KMS backups are a literal life-or-death scenario for your data. Without them, your recovered vTPM VMs simply won't boot. And number 4, do not rely on third-party backups to protect your vTPM keys. They simply cannot do it. I'll leave you with this mock exam question to test your readiness. An administrator enables Credential Guard on several VMs and notices an immediate drop in overall cluster VM density. What is the primary architectural cause? Take a second to think about it. If you immediately thought of nested virtualization overhead due to the VBS instance, you are perfectly calibrated for this topic. Thanks for joining this explainer. Keep studying, stay focused, and you are absolutely going to crush the NCP-MCI 7.5 certification. See you next time.